My name is Abi Way. I'm currently a student doing my master's degree. So I've completed my undergraduate degree in product design engineering, and I've always been interested in space. I was really fortunate to have the opportunity to do my placement year with Airbus Defence and Space, which was fantastic. I've now gone on to do my degree in design engineering, and I've got a graduate lined up in systems design engineering. I did my placement year with Airbus Defence and Space in innovation management, and I had a fantastic time. I was looking specifically at the current space ecosystem and what existing startups and SMEs Airbus could work with to help them progress and develop their idea and grow the whole space industry in the UK. And I was also looking at encouraging new innovative ideas within Airbus Defence and Space, helping them pitch for funding and sending those ideas to be developed properly into the business lines. So it was really interesting. So I grew up in St Albans, which was just north of London, and I got given a book when I was 6 years old, which was called First Questions and Answers on Space and Earth. And ever since then, I've been fascinated by space. I read all around it when I was in school, and I always knew that I wanted to one day work within the space industry. I wanted to do astrophysics ever since I first got given that book. But as I got a bit older, I realised that I enjoy practical work and I enjoy seeing how we can problem solve and how the physics and the knowledge in that area relates to everyday life. So I chose engineering because it was a route that fitted me better, and I wanted to apply that into the space industry. So I've been progressing my skills and my knowledge in that area and hope to bring that into the space industry. I was born with a condition called Oculocutaneous Albinism and Nystagmus. So it basically means that my eyes shake a little bit, which you might be able to see in this video. It means that I'm visually impaired. So for example, I will never be allowed to legally drive, and I'm legally classed as disabled. Although I'm wearing glasses, it doesn't actually fix my vision. So this makes things like recognizing faces a bit harder, reading text, and something that I found really difficult going through the education system is people understanding that I'm still just as capable as the rest of my peers, but I might need things to be written in a bolder pen, or I might need to be a bit closer to the screen. And something that's been really difficult throughout my studies in engineering is the software that we use is very inaccessible. So that's been a big challenge. To anybody else in a similar position, I would say if you want it, go and get it. I'm not going to lie, it is very difficult. There are a lot of challenges and barriers in the way, but I think those are skills that when you overcome them, you will have fantastic problem-solving skills. You'll be used to speaking and sharing your ideas confidently, and those are all things that will send you a long way in your career development. So I definitely advise, don't ever let anyone tell you that you can't do something. Go and get it. When it came to overcoming the challenges of my vision impairment, one thing that's really helped me along the way is my friends. Having them next to me and understanding, and sometimes reading things that the teachers said, or allowing me to copy a little bit from their notes if I've missed something, and learning to communicate my needs to the staff around so that they can help me as well. Sometimes it's been challenging when they've not understood and they've not been able to help me. I also have support when I'm at university with that software, having someone one-to-one to almost be my eyes. So they're telling me what they can see and describing to me how I can replicate it on my screen has been a big help. And I've got adjustments for my exams as well, things like extra time, rest breaks, someone who's able to read to me when my eyes get more tired. My GCSEs were quite challenging because a lot of the adaptations for my exams weren't in place as I was hoping they would be, so I couldn't see a lot of my exams. So that was the first big challenge, because you can revise as much as you like, but if it comes to the exam and you're not given equal access, it doesn't matter how clever you are and how much you know, that has a big impact that's outside of your control on how well you're able to perform in those exams. So I did well in my GCSEs, I got through to A-levels, but I was disappointed with some of my grades, particularly physics. I knew I could have done a lot better. My A-levels were particularly hard because of COVID, so a lot of that support I mentioned with my eyes disappeared. I didn't get the grades that I was hoping at my A-levels either, which meant I went through clearing for university. But I was fortunate enough to still get into a university I wanted, study what I wanted to study, and I managed to get a first-class honours in that degree, which I'm incredibly proud of. There were a lot of bumps along the way. One of my exams I got 8% in, not 80, not 18, but 8. This was a challenge because I couldn't see the content that was being taught properly. I really struggled to access the software, and that resulted in me getting 8%, which I obviously wasn't very happy with. Even when things go wrong, even when you end up with a horrific grade in one of your exams, you can still pull through and make it all come together if you want it. Having completed my placement with Airbus, which was a dream come true, I'm now doing my master's and progressing on to an engineering job. So for my final year project, I was looking into improving the design of spacecraft shielding to help protect our spacecraft against the increasing problem of space debris. So currently we use a thing called Whipple shields. The traditional Whipple shield consists of 2 pieces of aluminium with a set distance apart. The first is slightly thinner and the second is a lot thicker. So the idea is that the space debris hits the front, breaks into lots of pieces and splats on the back, and this prevents it getting through any further and damaging our spacecraft. I had the amazing opportunity to test my designs with Cranfield with their 2-stage light gas gun in collaboration with Airbus Defence and Space, and I was able to fire 3 aluminium pellets at it at a speed of 5 kilometers a second, which for reference is 12,000 miles per hour, which is crazy fast. So the first test was the traditional test, which went really well. As you can see, it went through the first hole and splattered very nicely as predicted in the end. Another design I tested was having a bumpy front surface, as you can see here on the front. And it went through and created a very interesting pattern on the back, which we don't think has been seen before. So this was very exciting and very confusing as well. So you can see all the different size craters in here, and you can see there's almost 2 lines, which is very different to the traditional where it's splattered in a circular pattern. Growing up visually impaired, there's been a lot of challenges throughout my education, and it's been a lot harder than it should have been. And that's why I've created Boomerang, which is going to be the first visually impaired charity aimed specifically at supporting and inspiring young visually impaired people into STEM. I'm very excited about Boomerang because I hope it will start to reduce some of those barriers and we'll see more visually impaired people in STEM in the future. Boomerang will have 3 key parts to it: a mentoring scheme where older people like me are partnered with younger people so that when certain parts of class are missed, for example, maybe they haven't been able to see a chemistry lesson properly, they can connect up with their older mentor who can help them through that chemistry lesson so we're not seeing those big gaps in knowledge that currently exist today. There'll also be an events, which is personally my favourite part. I've piloted this already, so it's all about getting these children into spaces that are adapted for them and they can access and learn everything in a way that's not usually accessible. So this is a 3D printed tactile moon that we used for the Boomerang event with Airbus Defence and Space. It's very difficult to imagine the moon, and I think we can all agree it's not something you can easily see anyway, but this is 3D printed and it's an accurate 3D print of the surface of the moon, which is tactile. So you can feel all the craters, and it provides a really good sensory experience for visually impaired children to learn and understand what the surface of the moon is like. Space interests me a lot because it's an incredibly fascinating area. I guess my response to that would be, what's not interesting about space? There's so much to learn, so much to do, there's so many unknowns. And having worked in the space industry as well, I can see it's an area where there's so much space for innovation and new technology and growth, which is something that's a lot more saturated on Earth. The potential is huge, and the amount of things to do and learn and engineer is huge with that as well, which is something that's very exciting to me.